Morning, nerds. That's right. That's how they're all going to start. Morning, nerds. You're all math nerds. Congratulations. You are Smarty Pantses and AP Precalculus, and today we are going to start Chapter 1, Functions and Graphs. Okay? We are not going to finish Section 1 today. We'll probably finish it tomorrow. The homework is on Schoology calendar, and in case you don't have a textbook yet, don't sweat that. I took pictures of the pages. They're also in class materials on Schoology. But since we're not going to finish the notes today, the homework is not due tomorrow. It'll be due the day after we finish the notes, which I'm hoping we'll finish tomorrow. Modeling and equation solving. AP is real big on modeling. And that's because math shouldn't just be numbers on pages. It should mean something. It should have real world value and use. So we're going to start with real world value and use the best way that I can imagine, and that's getting paid for something. Okay. So this table here is a bunch of data points. They're real. They are from the Consumer Price Index, and they track the minimum hourly wage, the minimum wage per year, and what the purchasing power of that is when you compare it to the 1996 dollar. What does that mean? That means this minimum wage of 75 cents per hour in 1955, whatever that equates to in 1996 is about $4.39 worth of buying power. So essentially we're saying due to inflation, 75 cents in 1955 is equal to $4.39 in 1996. Now, I don't have newest updated values for 2023, but we all know that inflation is a big thing in the nation right now. So imagine these numbers are actually much worse than they look. Okay. Anyway, we are looking at minimum wages from 1955 to 2005. We're looking at the purchasing power in the 1996 dollar. And these three questions are really just, can you read the table and see what's going on in the table? First one says, in which of the 5-year periods did the actual minimum wage increase the most? So you literally just look down the table and see which one has the biggest jump from one year to the next. And I'm hoping that you could do that relatively easy. Let's see. Looks like 0.25, 0.25, 0.35, 0.5 plus 1. Plus 85, plus 45, plus 45, plus 90, flat. So just by looking at the table and doing simple subtraction, I'm hoping that everybody can see that this one right here was the biggest jump of one whole dollar. We're literally just looking at the table and looking for the biggest jump. So what 5-year period? 1975 to 1980. Pretty easy, right? Just looking at a table, being able to read it. I said 75 to 80, correct? Okay. So this was the biggest jump, and it didn't ask, but it is plus $1. So we're talking about it. Part B is even easier. Part B just says, well, which year had the best purchasing power? So you can just raise a hand so I can learn some names. Which one has the highest purchasing power? All the way in the back, what's your name? Martin, which one's got the highest purchasing power? 1970 looks like the highest purchasing power to me, right there at $6.47. Worth of 1996 dollars. This is really old data. Maybe I'll get new data next year. Okay, now, part C is the most important question on here because it's not just look at the table and tell me a digit off of it. Part C says look at the table and based on what the table is showing you, what do you know? And we're going to be doing a lot of justifying our reasons in AP. You're not just going to be able to say answers. You're going to have to say answers and why you know they're true. It says, a worker on minimum wage in 1980 was earning almost as much as double what the 1970 minimum wage earner is making. So in 1970, we're only making $1.60 an hour. In 1980, it's $3.10 an hour, almost double. However, there was a lot of pressure to raise the minimum wage again. Who can tell me why? Looking for hands so I can learn some names. All the way in the back by the window. What's your name? Kate. Why do you think there was a push to raise the minimum wage even though we were already making almost double minimum wage what we were making 10 years ago? Yeah, you hit the nail on the head. Because the purchasing power went down, and you said probably due to inflation. Yeah, look at that. In 1970, your purchasing power was $6.47. 10 years later, that's less purchasing power, even though the minimum wage almost doubled. So we could say purchasing power decreased, and more than likely, that is due to inflation. While we're on the topic of inflation, it's a pretty big deal in the nation right now. This is my 13th year as an educator, and I've gotten a raise almost every single year, barring the very beginning when there was some really economic hard times going on where nobody got raises. Let's just say I've made a raise almost every year that I've been an educator. This is year 13. So it's been 12 years. I'm 12 years deep. And if you were to compare what I make now to what I made 12 years ago, yes, I do make, quote unquote, a lot more. But if you were to look at things like literally just the value of $1, which is kind of hard for people to wrap their head around, so let's say the price of groceries. 12 years in, I can now buy less milk with my salary than I could when I became a first-year teacher. And this happens very often. What that means is I have less purchasing power now, even though I make a substantially larger paycheck than I did 12 years ago. Yes, sir?
Back in 1980, you could buy a Big Mac meal for 50 cents. Now it's $10.
Big Mac meal was 50 cents in 1980?
Around that.
And you know what? I bet the food was higher quality too. I bet you it was higher quality food. So it's like salt in the wound. Like salt on the burger. She says I'm hungry. Yeah, I'm hungry too. Okay, there we go. Moving on. In this example, we will be utilizing our graphing technology. Not because it's the quickest way to do the question, because it's the coolest way to do the question. I need you to know how to use this technology. You will have to be familiar with graphing technology for your AP exam, for a lot of my exams. You're going to need to be able to do it for AP Calculus, which hopefully you all go to next year, or Calculus in college. If not, you're going to go to Statistics, either honors or AP. You'll need it there too. The point is, we need to know how to use this technology. So I'm going to flex my nerd brain here, and I'm going to show you how to use the tech. And even though it probably would have been faster to do it by hand, the point is we're going to use the technology. Okay. This table shows the growth in the number of prisoners incarcerated in state and federal prisons at year's end for selected years between 1980 and 2005. So we're looking at a chart of prisoners. Okay. And what it's showing us is the total number of prisoners times 1,000. So in 1980, there was 329,000 federal prisoners, federal and state prisoners. And in the year 2005, there was about 1.5 million federal and state prisoners. The data is then broken down into male and female. Again, times 1,000. Okay? I'm hoping everybody can see just by looking that the total number of prisoners does go up every year. The total number of male prisoners goes up every year. The total number of female prisoners goes up every year. Okay? That's what we can just see. The first question says, is the proportion of female prisoners increasing over the years? What is a proportion? Who can tell me how to do a proportion, just in general? Sebastian, what do you got?
It's like the percent compared to the rest.
Yeah, it's literally the percent compared to the rest. It's a fraction. So in order to figure out if the proportion is going up, I need to know what the proportion of female prisoners is every year. Now, I could either do female prisoners divided by total number, and that'll tell me what percent of the total population and whether or not that's going up. Or I could do female divided by male, and I would get a different proportion, but we could still see whether or not those numbers are going up. I would like to know the percent of total population. So here's what we're going to do. Instead of brute forcing and simply dividing at every step, which is probably faster to be honest, but I want you to know how to use the technology, we're going to turn our calculators on. The bottom left-hand button says on, blink, and there we go. I'm going back to my main screen. If your calculator gave you some kind of message like RAM cleared or something like that, you can tell it never show me that again by hitting the number 1 or by pressing enter by do not show again, whatever. We are going to input this data right over here into a table on this calculator, and we're going to ask the calculator to do the number crunching for us. And this will be used a lot in statistics if you go to a stats class ever. And if you go to college, almost everybody will have to take a stats class eventually. So it's good to know how to do it. Right here, we've got a button that says stat. And you see above it in blue says list. So that's how you know we're going to be building our lists and stuff. So we're just going to click stat. And then we're going to hit enter on edit. Now, if it's a brand new calculator to you, these will all be empty. If you borrowed one of my calculators, they all have a bunch of stuff in them. I'm going to show you how to clear it out regardless. I'm going to hit my left arrow till I get all the way to L1. I'm already sitting on L1. In order to clear a list, you press up. You do not hit delete. There's a delete key right there. Don't hit delete. It will delete L1, meaning L1 will no longer exist. L1 stands for list 1. Instead, what you're going to hit is this button right here that says clear. Boink. And then, bottom right, you'll hit the enter key. And the whole list is empty. So I'm going to go ahead and empty out all my lists. And if you have anything in your lists, please do the same thing. To the right, press up, clear, enter. To the right, press up, clear, enter. There. My lists are now empty. There we go. I'm not going to be entering the year this time because I'm not using it. This question talks about proportions and things like that. So what year it occurs in, it doesn't need to be in this table. I'm only going to enter total, male, and female. When you type a number like 329, you can either hit the down arrow to go down 1, or you can just hit the enter key, which again is right here. And I think it's faster since I'm already going to be working here. I'm just going to go ahead and hit this enter key after every number that I input. Make sure that you don't fat finger the keyboard. Make sure that you actually enter the numbers you meant to. I hate when people miss questions because they typed the numbers into the list wrong. 502, 774. Okay. I now have my total list typed in. Again, if you don't have your graphing technology yet, not a big deal. This is a video that you'll be able to go back and watch should you need to see how to do it. Go over to my next list. I'm going to let my male population be my L2. Same process, type the number in and hit enter. It'll drop down to the next slot. And then I'm going to have L3 be the female population. Same process, type the numbers and hit enter. There. Okay, so we haven't done any actual number crunching, and by the time we typed all this stuff in, we could have been finished with the question. I'm aware. I need you to know how to use the technology. You can decide when it was the best thing for you to do based on time, okay? Okay. I want L4 to be my proportion list. I want L4 to generate the proportions for me. So I'm going to go over, and I'm going to highlight L4. You'll notice down here it's got an equal sign next to it. That's allowing you to put commands in there. And I'm going to treat this like Microsoft Excel. I'm going to tell it literally divide. I want L3, female population, divided by the total population, which is L1. And to get it as a percent, like Sebastian said, I'm also going to tell it times 100. So how do you type L3, you may be asking? on the numeric keyboard, you will notice L1 through L6 in blue. That means you have to hit the blue second key to make it work. So I do second, and then L3, which was on the digit 3, divided by second L1, which is above the digit 1, times 100, so I can have my percents. And when I hit enter, it's going to populate all the percentages for me. Boink! There they are. Again, it would have been a lot faster to do that by hand, but right now we're seeing how to use the tech. Times 100 to get the percent. Yep. So they're small, but there they are. Question A asks us, is the proportion of female prisoners increasing over the years? So look at your percentages and you can see, I hope, that yes, the percentage of the female population is increasing. It increases at every interval. For part B, it says, well, which of the 5-year span had the slowest rate of change? Not the smallest proportion, because clearly the smallest proportion was the very first one. It wants to know about rate of change, which means the difference between each year. It wants to know which had the slowest growth. And for this one, you're going to have to use a command that I just learned last period. Okay? You might want to write it. Oh, my calculator is going to shut off. You might want to write down the instructions for this one. In fact, well, I don't feel like writing them because I'm going to show them on the video, but you might want to write it in your notes. I'm going to go to L5. I want L5 to automatically calculate the difference between each of these digits for me. Cool with that? This is how we do it. We press second. Now we're going to use this blue command of list. So if it says list, this means you are literally calculating things from your list. So second list, I'm going to scroll to the right to OPS. That means operations, ops. I'm going to the right to operations. So second, list, ops, and we are looking for number 7, delta list, where delta stands for change. Now you can either scroll down and hit enter on 7, or you can just type the number 7. I'm going to just type the number 7. It's now looking for an input. It says, well, what list are you trying to find the delta of? Meaning, which list are you trying to find the change in? You go, I want to know the change in list 4. So I'm going to have to tell it L4 with the blue second button and then the number 4. Second L4, be a good mathematician and close your parentheses, please. And then you hit enter again. Now I would like you to notice, yes, it did the subtractions for us, but I would like you to see that this list has one less term than the one before it. So what it's doing is it's showing you right here, this highlighted one was the difference of 4.5187 and 3.9514. It put that here. If that's going to bother you and you want it to line up, you want the number 6.6303 to line up with this, then what you're going to do is highlight 0.6303 and hit second, insert, and it will throw a zero in there for you, showing you that no, nothing changed from the first entry to the first entry. Huh? I'll show you again. You highlight this number and you hit second, insert, INS. You don't have to do that, but I'm a big fan of my differences lining up with the term that was the bigger number. This question says, which 5-year span had the slowest rate of change, which means all you have to do is look for the smallest delta. And not only could you do that, you could also look for the largest delta. You can see the largest delta was 1.1%, whereas the smallest delta is happening here right after the 1.1 at 0.3597. So this was the first, that 0 that's highlighted right now is associated with 1980. So if I wanted to go down to the smallest number, 0.3597, that is the fourth number down, 1, 2, 3, 4. That is associated with the 1990 to 1995 gap. It was the fourth digit down. So 1, 2, 3, 4. That's where the slowest growth occurred, from 1990 to 1995. From here to here was slowest. And if you wanted to know, because you were interested, if you look back at the list, the largest jump happened literally the span before it, from 1985 to 1990. If you wanted to know, I'm going to throw it in there because it's good notes. Oops. 85 to 1990 was the fastest. And if you wanted to get really, really deep into this, the question would be, why? I wonder why there was a large jump in female population in prisoners that group of years. I don't know the answer to that question, but it's a neat history of sociology question. We're finished with that for now. If you want to clear your lists, you can, one by one, or you can do the nerd thing and really know how to use your technology. Hit second, come on down here to the bottom, the plus sign where it says mem. So this is going to get me to the memory options. Second mem goes, all right, what do you want to do? And I can go down, I can just type the number 4 and it will clear all lists for me. There. And then hit enter. And it goes, done. All the lists are now empty. So that's faster than clearing them one by one. Cool? Might as well know how to use our technology. Set that to the side for now. Oh, we've already talked about cheeseburgers. Now let's talk about pizzas. A pizzeria, which, by the way, I think that I would have spelled this word wrong. I'm pretty sure I would have spelled that with an A. Unless it's spelled wrong right now and it's supposed to have an A. I don't know. Anyway, a pizzeria sells rectangular 18-inch by 24-inch pizzas for the same price as their large round pizza, which is 24 inches in diameter. If both pizzas are the same thickness, what we want to know is which of these options gives the most pizza for this money. Now, I don't want to know the answer. What I'd be looking for is for a handout there. Someone could tell me, what two numbers am I going to compare to answer this question? Who said that? Jack W. We will be comparing the areas of these two pizzas. So the pizza with the greatest area would be the answer. But let me ask you a different question. What if they weren't the same thickness? Not Jack W. A hand so I can call on a name. If they weren't the same thickness, what would we be using? Adi? You'd be comparing the volumes. So if they weren't the same thickness, we would need to compare volume. If they are the same thickness, we need to compare area. Good. Awesome. So I guess we need to know how to find the area of a rectangle. You guys know how to do that, right? Length times width. 18 times 24 is a number that I'm not even going to try to pretend I know. I fat fingered the keyboard. There we go. 432. So rectangular pizzas have an area of 432 square inches. And looking for a hand so I can learn some names of people who remember to find the area of a circle. Jack W, you already helped me. Sebastian, you've already helped me. Or Jack, I got to stop calling you Jack W. I'm just used to it. It's okay to be wrong. Charlie, what do you got?
Pi r squared.
Pi r squared is it. Now, those of you that weren't sure were probably trying to remember if it's pi r squared or 2 pi r, correct? So if pi r squared is area, what is 2 pi r? Circumference. Good job, whoever that was in the back that whispered it. But yes, pi r squared is area. Do you guys want to know a really easy way to remember that it's pi r squared and not 2 pi r? See how squared inches has an exponent of 2? And pi r squared has an exponent of 2 in it? That's because all areas are square units. Anyway, area of a circle is pi r squared. This is not the radius, this is the diameter. The radius would have to be half of that. So we're going to do pi times 12 squared, which, by the way, is 144 pi. But seeing as how most people don't know the size of 144 pi, and we don't know if that's bigger or smaller than 432, we grab handy dandy calculator and look where pi is. It's right here as a blue command. Mr. M, can I just use 3.14? No, you cannot. You will be wrong on the AP exam. Don't do that. What instead you're going to do is you're going to hit second, and then this button here is called caret. This is your exponent button. And your calculator now has a 12 on the screen. I'm going to open my parentheses, type 12, close my parentheses, and I'm going to square my parentheses with the squared button right here above everybody's favorite, logarithm. Pi 12 squared gives me 452.389 square inches. 452.389. Now, as soon as I did this question in second period, somebody asked me an extremely important question about the answer and the way that I wrote it. Anybody want to take a stab at what that was? What are we rounding it to? Because it matters. In AP mathematics, at least precalculus and calculus, you will always round to 3 decimals. Always. Unless there's less than 3 decimals. I mean, if it stops at like 0.25, because that's what it is, then that's what it is. But if your decimal goes past 3, your job is to round to 3. And you never round until the final step, ever. Because if you round earlier than the final step and you use rounded numbers to find later numbers that are rounded, you rounded rounded numbers, which is now wrong. Okay? Okay. Let's flip it over to the back and review some good old Algebra, technically 1 skills. We'll call them Algebra 2 skills. We're going to solve for x. Turning my calculator off right now. Here I have what should be a polynomial. Anybody remember the algebra skills? Just looking for hands so I can learn names. What it is that I have to do if I'm going to solve for x by hand first. Mark? Ah, darn it. No, Mark was absent. You're Mark's friend. Noah. From now on known as Mark's friend. Okay, Noah. Do you remember what you have to do to solve for x? It has to be set equal to 0. That means you have to get everything to one side. I'm a huge fan of my leading coefficients, meaning the number in the front of the thing with the biggest exponent, being positive. So because of that, since that's already positive, I'm going to move these 2 things to the left by subtracting them from both sides. Like that. Now I have a polynomial, 6x cubed minus 11x squared. What? Oh, I thought I messed up. Minus 10x equals 0. And we will solve by factoring. What's the very first step? We give our hands because I'm trying to learn names. I already know Adi. I already know Mark's friend, Noah. I need to know who remembers the very first thing you have to look for or try to do when you're solving by factoring. Looking for new people because I need to know names. And if I can't get new volunteers, I will find new victims. Yuri. You factor out the x. What he's talking about, thank you, is looking for the GCF. You're always looking for a greatest common factor. That doesn't mean there always is one, but that's always your first step. And all 3 of these happen to have an x in common, so I will pull that x to the front of the parentheses, leaving us 6x squared minus 11x minus 10. We are undistributing our x. There we go. Now the quadratic that we have inside the parentheses does factor. There's a very good chance that most of you have forgotten how to factor. For some reason, it's just a skill that doesn't seem to stick to people. There are several ways of factoring, and I don't care which way you choose. I care that you be good at it. So pick a method and be good at it. There are several methods. There's the tried and true and backed by mathematics AC method. The AC method takes this negative 11x, splits it into two appropriate terms that have x's on them, and then you continue by factoring by grouping. I love it. It's fantastic. Then there is ye olde guess and check method. Yuck. But I mean, the more you do of these, the faster you get it, guess and check. It becomes like an educated guess and check. Then there's two shortcut methods. And they are shortcuts because you don't know why they work. Those two shortcut methods, a lot of teachers use something called slip and slide. It's got some kind of like X diagram where you put things on the top and bottom of the X and things on the left and right of the X. I don't know that one. I use something called the Lizzie method. And if you want to watch some videos on how to do it, it's like that. L-I-Z-Z-I-E. No, I don't know why it's called that. I'm sure whoever figured it out, it's named after them. No clue. I'm going to teach you how the Lizzie method works. In this quadratic, we have a in front of x squared, b in front of x, and c is the constant at the end. Okay? The Lizzie method says, multiply a and c, figure out what you get. You're going to get a negative 60. Identify your b value. It's negative 11. Your job, and it is going to take some multiplication skills, so hopefully you have multiplication skills on lock. Your job is to figure out which two numbers will multiply to that negative 60 that are going to add to that negative 11. Now, Jack W., I heard you say him a few minutes ago because you are a thunder stealer, but what were those two numbers? Negative 15 and I'm going to say positive 4, but yeah. Negative 15 and positive 4. These two numbers do multiply to negative 60. They do add to negative 11. And we're ready to use the trick method. The Lizzie method is a trick. I want you to be aware of that. The AC method is not a trick. The AC method is how this should actually be done. And in order to do this using the AC method, you would have split this negative 11x into a negative 15x and a positive 4x. And then you would have proceeded to factor by grouping. That is the true method. But this is how the Lizzie method works. First of all, don't lose your GCF. So I'm going to throw that x on the front. Write your two sets of parentheses. We still have this equals 0. In the front of both these parentheses, we put an x. But Mr. M, I'm not familiar with the Lizzie method, bless you, but what I do know is if I try to FOIL right now, x times x is not 6x squared. This must be wrong. Trust me, this is why it's a trick. Okay? These two numbers, the negative 15 and the positive 4, they go in these parentheses. But I'm not just going to write minus 15 and plus 4. I'm going to do it like this. They're the top of a fraction. Remember when I said just a second ago, this x times this x will not get this 6x squared? That's because the 6 has been relocated to there. If you don't remember to put your a value underneath these numbers, you will be wrong every single time. I don't know slip and slide. I don't know how it works, and I think it's a ridiculous thing to say in a math class. It's called the Lizzie method. That's its name. I mean, that's its name, you know. So, now what you have to do is reduce your fractions. If you forget to reduce your fractions, you will be wrong every single time if you're trying to factor. If you're trying to solve by factoring, you might get lucky. But 15 over 6 reduces to 5 over 2, I think. Yes. And 4 over 6 reduces to 2 over 3. The next step of the Lizzie method, if you were trying to solve by factoring, you're actually done right here. The solutions are staring you in the face. There's 0, positive 5/2, negative 2/3. But if you're trying to finish factoring, See how we took the 6 and slid it underneath those numbers? If you still have a denominator, you have to put it back in front of the x. This is a shortcut and a trick, and it has a couple different places where you could forget how to use the trick and therefore be wrong. Okay? If you were told to factor, it factors to x times 2x minus 5 times 3x plus 2. We were told to solve, so we actually didn't need to do that last step. We can see our solutions here. Our solutions are whatever makes each x zone equals 0. There's an x outside of the parentheses. I don't care what numbers are out here. There could be a negative 17/3 out here with it. I don't care. Because there's an x on the outside, it's automatically 0. And then in this x zone, all you have to do is tell me the opposite symbol, because dropping a positive 5/2 here would give me 5/2 minus 5/2, which is 0. And then here, a negative 2/3. Because if you were here, you'd have to set 2x minus 5 equals 0 and solve for x. And here you'd have to set 3x plus 2 equals 0 and solve for x. And one more question. Paul, what's up? Okay, yeah. Decimal to a fraction, I can show you at some other point in time. That's where this lesson is going to end for today. We will pick it up tomorrow, and because of the fact that we haven't finished the lesson, the homework is not due tomorrow. That doesn't mean don't start it. You should start it. I'll stop the video.